Hey there, kiddos. Today we're going to talk about something called linear regression, which is a way for your calculator to take 2 points or more, but at least 2 points given on a graph, and give you the equation for the line that would best fit those points. Sometimes it's the exact equation for the line because they make a straight line, your points line up perfectly, and that's what happens. Sometimes it's the line of best fit, and it's a weird kind of strange equation because your points are scattered in a scatter plot and they're not necessarily all lined up in a straight line. So let's see how this works. Oh, one other thing. Now that you are going to know how to do this, you're going to know how to use your calculator to generate the equation of a line. You may use this to check your equations for your line project only. You may not use this method to do them. You must do them algebraically first, and then if you want to make sure they are correct, you can pull out this and you can use your calculator to check them. But you need to have the algebra to back it up. So here's what we have. A chemistry experiment generated over time reported the following temperatures for a solution. After 5 minutes, the temperature was 75 degrees, and after 15 minutes, the temperature was 130. What are the ordered pairs, and what would they represent in this situation? Well, in our problem, it tells us that after 5 minutes, we're at 75 degrees. And after 15 minutes, we're at 130 degrees. And so what do these represent? They represent the ordered pair that is minutes and temperature, where minutes is your independent variable and temperature is your dependent variable. So next they ask for the equation of the line, which we know how to do algebraically. Now we're going to do it using our calculator. So we're going to get out our calculator and we're going to press this button called Stat. It's the one that lit up in red, and you should get a menu that looks like this. We want to edit, so you can either press 1 or enter, and you should have a screen similar to this one. I think you on your calculator only see 3 lists at a time, but what you want to make sure is that you have an L1 and an L2. If you do not have an L1 and an L2, I'm going to show you how to fix it. If L1 and L2 are missing, you press Stat, but this time you want to do Setup Editor, and so you have to go to option 5 and press enter. And it'll tell you that it's done that. And then if you go back to Stat and then Edit, you should have your L1 and L2 back. So if they disappear, that's how you fix it. But if they're already there, you're good to go. So I have stuff in my list, and you might also have stuff in yours. And so here's how we clear a list. We press our cursor until the L1 or the list we're trying to clear is highlighted. Okay? And you don't press delete. No, 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 no. Don't do that. You press clear, and then you press enter, and it will wipe out that list for you. If you press delete, it's going to delete the list, and you're going to have to do that setup editor step again. So we can go over here to list 2, and I will also clear and enter that one. And so X values will go in list 1, Y values will go in list 2. And so my 2 points, my X values were 5 and 15. So I hit 5, enter, and then 15, enter. And then my Y values were 75 and 130. So I have 75, enter, and 130. My calculator's being super sensitive. 130. There we go. Enter. So now I have those numbers in my list. Now I'm going to tell my calculator that I want it to create what's called a linear regression based on those 2 points. It's going to look at those 2 points. It's going to do a little formula in its little noggin, and it's going to come up with the line that matches those 2 points. And so we're going to press Stat again, but this time we want to calculate something. So we're going to right arrow over, so Calc is highlighted, and we now have this new menu. We want to do LinReg. This is linear regression, and if you will notice in parentheses it says AX plus B, which looks a whole lot like MX plus B. Why the calculator switches it to AX instead of MX, I don't know, but it's the same thing. AX plus B, A is your slope, B is your y-intercept. So we're going to go down to option 4, and you should have a menu like this. Now some of you, it might just say LinReg at the top, AX plus B, and you don't have all of this. It's okay if that happens. It just means your calculator doesn't have the new operating system. And so you can just hit enter. If you have this, you have to hit enter all the way until you get down to calculate, and then hit it one last time and it will calculate for you. And so now here's what we have. It says LinReg, y equals AX plus B, and it tells me A is 5.5 and B is 47.5. To write my equation, I'm just going to substitute these values into AX plus B. So my equation is y equals, A was 5.5x, and B was 47.5. Whoops, wrong. So I have plus 47.5. So there is my equation that goes through these 2 points. That's the equation of my line. So C wants to know what is the slope and what does it mean. Well, in this case, our slope is 5.5 because it's the number in front of the x. Now, what we have going on is minutes and temperature. And so if I had this on a graph, minutes would be here, temperature would be here. And so when I'm doing slope, remember, it is rise over run. So it's the y values over the x values. So what I have in terms of meaning is the temperature per minute. And since this is positive, it tells me that my temperature is increasing. So what that means is that it is the amount the temperature increases every minute. So it means that the temperature increases. My dogs are fighting. Please excuse the noise. Temperature increases 5.5 degrees every minute. That's what that tells me. So now what is the y-intercept and what does it mean? Well, my y-intercept is the b, or the 47.5. And if you'll remember when we talked about this way before, y-intercept is always a starting point of some case. And so since y is temperature, then this was the starting temperature. So at the beginning of the experiment, the solution was 47.5 degrees. So now they want us to predict the time it would take for the temperature to reach 64 degrees. Well, temperature is the y value. So you have two options here. We can plug 64 into this and we can solve it, or we can again use our calculator. So if we go back to our calculator and we press this button up here called y equals, you should get a screen similar to this minus the colors. And we're going to enter our equation into y1 here. So I have an equation. I'm going to clear that out. And I'm going to type in the one I have. Well, the one I have is 5.5x, which is this button right here, plus 47.5. That's my equation. And if I want to be able to go look and find out when the temperature is 64 degrees, I need a table of values. So I'm not going to graph it because what the line looks like doesn't really matter. What I need are values that are on that line. So I'm going to press second and then graph. And it will take me to the table that matches this equation. I had to change a setting on my calculator that you probably didn't have on yours. And now I need to find where the temperature is 64. Remember, temperature is the y value. So I'm looking in this column that's blue, and right here is 64, and that's after 3 minutes. And so my answer, it would take 3 minutes to get to 64 degrees. I could also, if I didn't have my calculator, didn't know what to do, plug it into this equation like this. And I could use my algebra skills and I could solve that equation for x and my answer would be 3. But your calculator will do it for you once you know the equation. So let's do another one. Number 2. This table shows the dosage of a particular medicine as related to a person's weight. It says, using your calculator, create a scatter plot. We're not going to make a scatter plot. What we're going to do is part A. We're going to find the equation of the line of best fit, approximated to the nearest thousandth. That is 3 decimal places. Okay, so when we do this, we're going to have to practice rounding to 3 places. So the first thing that has to happen is I got to put these in my calculator. I've got to put this stuff into my list. The dosage of the medicine depends on the weight of the person, so that means dosage is dependent, weight is independent. So weight's my x, dosage is y. So I'm going to go over here to my calculator and I have to enter in those numbers. So I go back over to here, I'm going to press stat and then edit again. And I have numbers in those lists, but I'm getting ready to enter in a whole bunch of other ones, so I don't really have to clear this time. I can just type over them. And so my numbers, my weight first, I have 90, 100, and 110. Those are the first 3. So I have 90, 100, 110. And then I have 125, 140, and 155. And then I have 170, 180, and 200. So see, I messed up. If I want to fix it, I can just arrow up until I'm back over that, and I can just retype over it, and it will fix. Now I'm gonna pause for just a minute and enter my y values. You should do the same thing. So now I have all my values in my list, and the very first thing you want to check is you want to make sure that your 2 lists are the same length. Okay, you don't want to have a number down right here and not have a number over here that matches it. They need to be the same length, or what we're trying to do does not work. So now we got to find the equation. So we're going to go back to stat. After we press stat, now that we have our points in there, we want to go over to calculate again, and we want option 4. We want to go calculate, to do a linear regression. So you go hit enter until you get down and calculate, tell it you want to enter it, and it will give us our equation. Now here is one where if I were to put these points into on a graph and make a scatter plot out of them, they would be scattered everywhere. It wouldn't make a perfect pretty line, which is why our equation is weird, because it's a best fit line. And in this case, it doesn't match every single point, so it's a weird little equation. So we got to round to the nearest thousandth, which is 3 decimal places. 1, 2, 3. This 9 means I have to round the 7 up to an 8, so it becomes y equals, I'm sorry, Honey is in here. She's decided she needs to be in the room with me, and she is barking at a blanket. We'll try and ignore her. Then my second number is negative 26.7876. This 6 is going to round that 7 to an 8. So it's going to become minus instead of plus this time because it was negative. 26.788. So there's my equation to the nearest thousandth. Now we're going to predict the dosage for someone who weighs 240 pounds. Which means I'm just going to plug in 240 for x. I can do the table function like we did a minute ago on this, but I don't really want to scroll down to 240. 240 in for x. So we're going to go y equals 0.508 times 240 minus sorry, my dog just stepped on my computer and then she got yelled at, so she's laying here pouting. Hopefully we can get through this without any more major destruction. So, back here to our equation. We're plugging in our x value of 240 into this equation. And then we're going to go back to our calculator and we're just going to type this in and have us do it. So we're going to go, we're already at the screen. You can hit clear if you want to, or you can just leave it. It doesn't matter. So I have 0.508 times, or parentheses, 240 minus, and I gotta go look up the number, 1 second, 26.788. So 26.788. And our calculator will just take care of that for us. And it tells me that it's 95.132. Well, we're dealing with dosage of a medicine in milligrams, so we want that to be a whole number. So that's going to be 95. So someone who's 240 pounds is going to take approximately 95 milligrams of the medicine. So I'm going to leave this to you. You have 2 more problems. You have number 3, and then on this back page back here, you have number 4. I am going to allow you to choose which one you want to do. You either should try number 3 or you should try number 4. I want you to plug in the points into your calculator in your list. Then I want you to find me the equation, and I need you to have an equation. And tomorrow when you come in, I will check and make sure that you have one of those 2 done. It is part of your notes. You must have 3 examples completed, the 2 we did together, plus either number 3 or number 4 to get full credit for your notes. So I'm going to let you try either one, and then I will see you guys tomorrow when you get to class.